To test null sigma equals 2.5 versus sigma greater than 2.5, a random sample size 22. If the sample standard deviation is 2.8, compute the test statistics. So you know that you will do the variance stats here because hypothesis is about standard deviation. Okay, so stats, variance stats, one sample summary. And we need sample variance here. They give us sample standard deviation 2.8. So you square it. Square of 2.8 is 7.84. And the sample size is 22. And then the hypothesis test, sigma equals 2.5, and this needs square of fifth sigma. So 2.5 square is 6.25. And then we have greater than. So 26.342. For 2 decimal places. P-value, okay, it was there in StatCrunch, 0.1937, so 0.194. And P is greater than alpha, so that criterion still holds, that reject the null if P is less than alpha, and do not reject the null if P is greater than alpha. So P-value is greater than the level of significance, which is alpha. So the researcher will not reject the null. Okay, test statistic again. So stats, variance stats, one sample summary. Okay, sample variance will be the square of 1.3, which is 1.69. Size is 17. And then it's equal to 2.4 for sigma, and then the sigma square will be 2.4 square, which is 5.76. And not equal to. So 4.694. Okay, the critical values can be done through the chi-square calculator because the test is about standard deviation. So I do the chi-square calculator. Stats calculators, chi-square. Degrees of freedom will be 1 less than the sample size, so 16. And now remember the between is the two-tailed, this is two-tailed because we have not equals to. So the two-tailed is done by doing the between, and instead of using alpha, we use 1 minus alpha. So 1 minus 0.10 is 0.9 in the area. So 7.962 and 26.296. Now, the convention is that actually here they're forcing us to write certain order. So the chi-square of the lesser value, that's actually the right value. So that'd be 26.296. And the other one will be 7.962. Okay, and this is two-tailed, and this is the one which has two tails. All right. And then for the rejection, we can just use the p-value. So where is that crunch? Okay. So where was the p-value here? Okay, let's do it again then. Well, I don't want to do this again, so let's just use the critical values. So the critical values are 7.962 and 26.296. So this is like 7.962 over here, and then over here it's 26.296. And now you have to see whether the test statistic falls in the critical region, which is the shaded part, or does it not. So the test statistic was 4.694. So 4.694 is not between these two. It's actually on the left of 7. So once again, this one was 7 and this was 26, and the 4.692 would be somewhere here. So actually it is in the critical region. So you will reject the null because this 4.6 is less than. So, okay, they were not asking for the numbers. They were just asking to see if the test statistic falls in the critical region or not. And it does, because it falls over here. This one is 7 and this one is 26. So the 4 falls over here. Okay, so yes, because the test statistic is in the critical region. Critical region is the rejection region in the tails.